Hi guys, welcome back to the channel. So today we are going to be solving today's Leetcode question, which is maximum rectangle. So we are given a matrix which will consist of rows and then columns, which will consist of zeros and then ones, and then we need to find the largest rectangle, which will consist of only ones, and then we need to return that particular area. Suppose if we consider this particular matrix, now we have different rectangles. One one rectangle is going to be like this, and then the other rectangle is like this, and then the other rectangle is like this, and then one more rectangle is this one. So this is the maximum area of this matrix, which will have this particular rectangle, and then which will consist of only ones. So we are going to return this particular length. So now if we want to do the brute force approach, then we need to consider each rectangle, each endpoint. Suppose let's say I want to start from here. Then for this, I need to pick I and then j, and then I need to pick the matrix which rectangle which we can build from here, and then we are going to consider again row, and then we are going to consider total matrix which will have only ones. So for that it will take a lot of time. So we need to optimize this particular solution uh, by using different approach. Suppose instead of considering this as a matrix, let us consider that we have different heights at this particular row. That means let us divide this particular matrix into rows. Suppose let us say that I have this particular row which will have this particular heights, which is 1 and then 1, and then for others is 0. So for this, when we consider this particular row, we are going to consider height as 2, and then for this we are going to consider height as 2, and then for this one, and then for this one. So now at this particular row we are going to consider height as 3, and then for this 3, and then for this 2, and then for this 2. And then using those particular heights, we are going to consider the maximum rectangle which we can build for that particular row with the particular heights. Suppose let's say this is a example where we have 5 and then 7 and then 6 and then 10 and then 4. Now we need to find the maximum rectangle using these particular heights. Suppose let us consider that we have 5. For this we need to find the maximum rectangle which we can build with this particular height as 5. So to build this particular height with a 5, we need to see the rectangle, we need to see the length of this particular rectangle which we can build. Suppose let's say this is 7. Yeah, we can use this particular 5, and then for this it is 6, so we can use this particular 6, and then for this 10 we can use this particular 5, and then for this the height is 4, so the 5 will be like this, and then 4 will be like this. So the this height is not possible to build this particular rectangle with the height of 5. So we cannot go above this particular above this particular ending. So let's say that we have this particular different heights. For this, if we want this particular 5 height, we need to consider index which is just less than this particular height, which is going to be left, and then the index which is going to be right at this particular case, and then we need to consider that particular index. And then for the length we are going to say that it is going to be r minus l minus 1. So if you want to derive this, then the length is going to be for this r minus l plus 1. So the r is going to be r minus 1, and then length is going to be l plus 1, and then again we are going to consider plus 1. So if we do this, plus 1 and then plus 1 will get cancelled, and then it is going to be r minus l minus 1. So this is going to be our answer, and then we need to maintain such a way that the stack, it will be using the stack for this. Suppose let's say I want to consider 6. If I want to consider the case of 6, then I need an index of 5. I need an index of 5, and then I need an index of 4. That means I need to find the index which is lesser value than this particular value. So I'm going to store, let's say for this, if the stack is empty, we are going to consider the index as -1. So the stack is empty as of now, and then we are going to push 0 as our index. So this is going to be 0, and then 1, and then 2, and then 3, and then 4. Now at this particular 0 we are going to push this particular 0, and then again we are going to come up with the 7. So for this 7, this particular length is greater, so we are going to push this particular uh, one index, and then now we have 6. So if we want this particular 6, then this 7 is greater than or equal to this particular 6. That means we will take out this particular 7. Why are we taking the out this particular 7? Why? Because suppose, let's say, if we consider this particular rectangle, we cannot consider 7 height eh, other other than this particular 6. Why? Because suppose if we take this particular rectangle, I want the height of 7, then we cannot get that from here itself, and then we cannot get here as well. So that's why we are going to remove this particular 7. So I'll remove this particular 7, and then again this is less than this particular 6, so we are going to insert this particular 2, and then for this, whenever we are removing this particular 7, we are going to consider index of this, and then we are going to consider index of this back. So which is going to be 2, 2, and then minus of this one is going to be 0, and then this is going to be 1, and then into 7. So which is going to be 1 into 7. So we got this particular area. So this is going to be 7, and then we'll go to the next element, which is going to be 10. So this is greater, so we are going to push 3 index, and then again we are going to consider 4. So the 10 is greater than or equal to this particular 4. So that's why we need to remove this particular 10. So whenever we are removing this particular 3, we are going to consider index of this one, and then the previous index, which is going to be, and then again we are going to remove this 6 as well. So we are going to remove the 6 as well, and then for this we are going to calculate by taking this particular index, which is going to be 2. So 4 minus 2 is going to be 2, and then again we are going to do the minus 1, so which is going to be 1, and then 1 into 10 is going to be 10. So we are going to maintain the maximum value of this particular area, which is going to be maximum of 7 and then 10, and then again we are going to consider removing this particular 6, which is going to be at the 2. So we are going to remove that. After removing this particular 6, we are going to consider the index of this particular 4 as well as the index of this particular 0. So which is going to be 4 minus 0, which is going to be 4, and then again we are going to do the minus 1, which is going to be 3 into this particular 6. So which is going to be 360 18. So we are going to consider as 18 the area, and then again the 5 is greater than or equal to 4. So for this we are going to consider index as this particular right, and then again we are going to consider the negative minus 1 as our answer, and then 4 minus 1 is going to be, so 5 is going to be this, and then 4 minus 1 is going to be 3. 4 minus 1 is going to be 5, and then we are going to do one more minus 1, which is going to be 4, and then 4 5 ja 20. So these are the different areas. One is 7, and then 10, and then 18, and then 20. So this is going to be our answer, which is going to be considered for this 1 2 and then 3 and then 4, and then again this is 5, and then 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 for this are we going to consider this is going to be 4. 4 minus of minus 1 is going to be 5, and then 5 minus 1 is going to be 4. Yeah, 5 into 4 is going to be 20. Yeah, for this it is going to be 20, and then we'll be returning this particular area. So that is going to be our approach. So we will be taking the stack and then we'll be using the only one row for this particular case. Suppose let's take that we want to calculate the maximum rectangle using this particular matrix, and then we are going to calculate the height of this particular bar. So which is going to be like this. For each row we are going to consider the bar. For this row it is going to be like this, and then for this row it is going to be like this, and then for this row it is going to be like this. So we are going to consider in this h of n plus 1, and then we are going to take matrix of size, and then we are going to consider each column, and then whenever we are considering each column, we are going to say that if the matrix of ij equal to 1, then we are going to consider the previous height plus this particular one, which is going to be increased. And then whenever we say we have matrix of size j equal to 0, then we are going to consider height is equal to 0, and then at last we are going to assign as 0, and then we are going to calculate the largest rectangle area with this particular row height, and then at last we are going to return the answer. So let us see the largest rectangle area using the height bars. So we'll take the height size, and then we are going to take answer equal to 0, and then we are going to consider each column what will be the size. Suppose let's say the previous size is greater than 0, and then this particular height is greater than or equal to whatever the considered height. Suppose let's say we have here this height is less than or equal to this particular 7. That means this height cannot be part of uh, other bars. So that's why we are going to remove this particular height. So we are going to consider that, and then whenever we are removing this particular back, we are going to consider the particular height with the previous index as v dot back. That means we are going to consider this particular height with the previous index, whatever the previous index whose height is less than this particular height. We are going to consider that particular index, and then we are going to consider the right index as our I, which is going to be I, and then this is going to be our index, and then we are going to do the -1, and then we are going to calculate the maximum height, and then at last we are going to push the I. And then one more thing we need to observe is we are going to push height of j equal to 0 at last. Why? Because suppose let's say we have uh, here different heights, and then here we have 4, and then if we have 0, then we are going to remove this particular 4 height, and then we are going to consider the rectangle of this particular height. That's why we are going to consider this 0 as our extra element, and then at last we are going to return the answer. So for this, if we come to the time and then space complexity, so here we are going to consider m, and then here we are going to consider n, and then after considering n, here we are going to consider n as well. So this is going to be the time complexity is going to be m cross n, and then the space complexity is going to be big of n. Why? Because we are only considering this particular vector, which will consist of all the columns which are present in this particular matrix. Yeah, that's all for this video. Thanks for watching the video.